As we begin to look at applications of vectors, a lot of times we make connections to velocity. Velocity is a common term that we use. It has both direction and a magnitude, you could say. A lot of times when we connect it to vectors, magnitude is going to represent the speed. So when we talk of velocity, it tells us direction, speed. A vector, it tells us direction and magnitude. The magnitude will just turn into speed for our applications. So if we were to think of a plane flying, they fly on a certain bearing. It's important to go back to the application unit that we did with trig. And remember that a bearing starts from straight north and moves clockwise. And all of our math formulas use unit circle ideas, where we start kind of at the 3 o'clock position and we're going counterclockwise. So this is going to get a little complicated in our pictures if we happen to forget that. So in this question, we have a plane that's flying on a bearing of 65 degrees at a speed of 500 miles per hour. We want to find the component form of the velocity of the airplane and then describe what that means. So first, let's start off with a picture. Let's say that this kind of represents maybe the origin there is maybe where the plane took off from, and it's going to fly on a bearing of 65 degrees. So maybe something off kind of in that direction. Okay, the bearing was 65. That's from straight north here. That's 65. But any math thing we have to do has to deal with that angle right there. And that would be, those two angles together add up to 90. So this would be 25 degrees. Okay, the 500 is just going to be the length of our vector. So the magnitude there is 500. So they say find the component form. That means find the values that would represent this coordinate right here, and then write it with those special brackets. So we've learned throughout the course of this unit that if we want to call that vector v, what we're trying to find, that's simply going to be the magnitude times cosine, and then the magnitude times sine. So we'd have 500 times cosine of 25. Whoops, forgot the s there. Cosine of 25. Okay, with a comma. And then we'd have to have, can I squeeze that in there? I don't think I'm going to be able to. So I'm going to put this on the next row here. 500 times sine of 25. And then we'll close that parenthesis. So that's all one vector there. And then it's just simply putting that into our calculator, making sure we're in degree mode. Of course, that would pop up. I'm going to keep writing here. So we'd have 453.15 for the x value, and we'd have 211.31 for the y value. Then we just need to think about what that means. So if I think about that, the x value in this form, that's how far we went to the west. The 211, that's the y value. That's how far we went to the north. So get a different color here. This talks about, in this case, how far west we went. I'm sorry, not going west, going east. My bad. Ask me about my second grade experience with west versus east in class, and I'll tell you a funny story sometime. But I'm not going to tell you in the video. So we're going to the east for this, and this is telling us how far to the north we went. And there are certain times where that would be useful to know. Okay, I'm going to stop it right here. Our next example takes a little bit longer to run through.